Hi. So we're going to talk a little bit today about TrueCar and how data really drives the automotive business. And we're going to go a little bit into our journey down the path and some of the benefits that we were able to get. So a little bit about TrueCar. TrueCar's mission is really to show that transparency is a better way to do business. Buying a car is a pretty stressful thing, and both sides of the equation, both the buyer and the car seller, don't tend to have great clarity into the data. And it's something that really sort of hampers the entire process. The TrueCar platform is really designed to dissect and display data in a way that's really relevant to the transaction. And so there's a number of challenges around that. Visit our website, check it out. It's pretty neat, some of the things you can do with data through our website and our mobile apps. And we're a recently public company. So a little bit about Russ and I. My name is John Williams. I'm the SVP for Platform Operations at TrueCar. My responsibilities are really all the operational aspects of technology and our strategy. I also get heavily involved with data, both from an infrastructure perspective, but I also really work on how we think about data, how we approach that, and how we're actually going to bring data to bear, both from the plumbing side as well as sort of the philosophy behind it.
Yep, and I'm Russ. So to John's platform and infrastructure, my team supplies the content. And just for reference, we use John's bio as the initial developer word count on Hadoop example.
So a little bit about how our core service works. One of the fascinating things about TrueCar, we're providing information to both sides of a vehicle transaction. And we've got a pay-per-sale model. So what's really fascinating about this is we only get paid if the car is actually sold. So it means we have to do a lot of things with data and do them in a really accurate way. Because if you're off by even a little bit, the car's not sold, we don't make any revenue on that transaction. So we've actually got a website that many of you may know from our TV ads and other things. But we also power white labeled car buying sites for many different affinity groups, insurance companies, banks, folks like that. And it's a fascinating aspect of our business because although we're a relatively small company, we try to move fast and be really agile. We also have to meet strict standards for security, compliance, availability. Our banking and insurance partners make very specific prescriptions about how we have to protect the data that they give us. So we really sort of have to master all the traditional aspects of data science and data handling, as well as trying to be innovative around that.
So, and to get a little bit more into the details of that, and this will build up as we do this presentation, this is the situation that John and I, as partners, are dealing with at TrueCar. Obviously, as a company that's almost a decade old, recently public, made up of several different companies, we have a growing product set. We've never reduced the number of products we like to put in the marketplace. So we're just dealing with a ton of innovation on the product side. And then combined on John and I's side, there's a growing tech diversity. And I'm sure that many of you experience that too. And that goes from the number of programming languages that we use. We're fairly open about letting people do what they need to do to get their jobs done. But on the data side, we have over 5 different database systems in play right now. And then in terms of the analytic tools and the things on top of that, it's a growing set of things that we have to manage and make sure operate against all the partner commitments, et cetera. And then, of course, like I'm sure almost everybody at this conference, or you wouldn't be here, we have a ever-growing appetite for data. I could not figure out a better graphic than this is how it feels to me internally, is that we just want to keep eating data as fast as we can. What this ends up resulting in, and hopefully the graphic on the right side for everybody makes sense, is that's Katamari. If you played the video game, you're just constantly rolling over more shit and making bigger balls. And that's what it feels like to John and I sometimes with what we've allowed on the left side. On the right side, we're spending a ton of time just keeping it all together. Being a company that was started almost a decade ago, we have a huge amount of SQL in our code base, and that to do some of the things that we need to pull off on a daily basis, there's a lot of wizardry in that SQL layer, which isn't necessarily bad in and of itself, except if you have this growing appetite to keep doing things faster and in compliance. And then, of course, the last big chunk of this is just data movement pressure. We are moving a ton of data, industry data, our own internal data, throughout the day, and it's putting tremendous pressure on our infrastructure.
So when we looked at big data and what it was going to mean for us, we realized that we wanted sort of a wholesale shift in how we approach data. So we quickly realized this wasn't just going to be about the economics. This wasn't just going to be SQL that's cheaper or reducing costs. We really wanted new capabilities, from the new technology that we chose. So we really went into this not necessarily looking for replacements for legacy applications. Certainly that was a part of it. But we were also really looking for absolutely new capabilities, being able to do completely different things that were just fundamentally impossible with our current infrastructure.
And those capabilities that John's talking about relate to not just the actual technical stack, but also to the development and management layers. We very much believe that people are the primary technology in our business, and we wanted to make sure they had a whole new capability set to go forth.
So one of the really crucial pieces of the puzzle really is not technological at all, right? So it's an organizational design problem. And we actually realized that making SQL go faster, that's not the primary goal that we're going for. One of the things that we do as a business, a lot of businesses have this interest, is identifying and breaking down silos within the organization. And we discovered that it's sort of a fractal problem where you can zoom in and find silos even within the skill sets. So certainly SQL was something that we had dedicated folks that spent a lot of time, a lot of effort, a lot of money around things that are just purely SQL. Same goes for other aspects of data science and other aspects of our problem space. And we decided that we wanted to fundamentally change that too. And we viewed that as central to the ability to get new kind of features and functionality from our tool set. So we're really trying to sort of break down, data scientists, database developers, programmers. We're really looking for a new kind of blended role that's more of an intelligence engineer, somebody that can work on a wider spectrum of the stack. And that's going to happen partly by reducing the space of the stack, but also really looking at, how can we get arbitrary technology out of the way and let brainpower focus more directly on the problems that are unique to our business.
Yeah, I think that's a good articulation. And the key here, and you'll see it throughout the rest of the presentation, is intelligence. We want everybody who's working on building cool things at TrueCar to all have a very good handle on the type of intelligence we're trying to drive in the marketplace. This, I think, is probably a somewhat audacious goal that John and I are chasing, but we just believe that over the long term, we can't have those silos of data scientists, developers, programmers, analysts, product managers, all the way down in such a way that they don't fundamentally understand the basis of our business, which is data, integrating data, moving data, and finding interesting things in that data. So to that point, and John kind of hinted at it, we want to remove from the engineers stuff they have to think about, anything involving the infrastructure. I don't want them worrying about if we have enough hardware. I don't want them worrying about if they're going to run out of space and what they're doing. I didn't want them worrying about the scale of the system. I certainly don't want them moving tons of data simply because we have disparate systems. In a sense, I want them to not worry and be happy and focus on making really smart things. The fewer things they worry about in terms of just raw general technical things, the better. The more that they do worry about how much smarter is our stuff getting relative to the competition, that's a good thing to worry about.
So one of the interesting things that we noticed, if you look at the development model and how quickly we can go from an idea to a fully realized product in the marketplace, we really asked ourselves, where does the time go? How do we optimize? We want to be faster and quicker and more agile as a business. And what we realized is a tremendous amount of the time goes into things like SQL, something purely technological that's not specific to our business. And you know what that really meant was we would look at a data set that we wanted to process, and we'd realize that a lot of the effort is, well, I got to come up with a schema that I can plug that data set into. And then I got to write a parser and an ETL process to do that. Then I got to think about how indexes are going to work. Then I'm going to write queries against it. Then I'm going to try to optimize that. And by the way, if anything about that data changes, the formats, anything, I probably have to go back and rebuild some or all of that process. So our goal really was try to get to an entirely new model, right? Get away from these limitations and make more of the time focused on the part of the problem space that's interesting and unique to our business. What that really meant was basically getting all the data we can, putting it into HDFS, and writing parsers that are more intelligent, that can operate directly against the data. Fundamentally, there's this thing where we're working on transactions that happen in the real world. So they're unstructured. The real world is unstructured. So we don't want to have the inefficiency of taking unstructured data, making it structured, and then putting it right back into an unstructured state in the world, right? So we want to be able to natively handle the unstructured data.
Yeah, and I think, from my standpoint of running the software side of the data platform, I don't want developers to have to worry so much up front about getting everything perfect. The idea that you can just kind of dump everything you've got somewhere, and then a bunch of different development teams can get to work on doing useful things with it, and it's non-destructive in the things that they're doing, that's a very powerful thing.
So one thing that we did at TrueCar at the outset of our journey, we really came up with a philosophical approach to big data. And this drove many aspects of our adoption over time. And we really started to look at some of the economics behind it and how we were going to monetize data. And we realized that, first of all, the economics are so good, it's so cheap to store data, that it just doesn't make sense to ever erase it. And when you look at sort of an infinite timeline, because I'm going to keep the data forever, I now have many opportunities to come back and come up with new ideas to remonetize old data. So once you sort of accept the reality of that, it turns out that it's true that data fundamentally is money. So of course you don't want to throw that away. This is especially true when you start to think about machine learning approaches. I got to train the machine learning, so the more data I have to train my models, make smarter models. So just that example alone really shows that data is money.
And the reality of the automotive business is that you're not talking about a transaction that exists only in this instant. Typically, people are refreshing their cars every 5 to 7 years. We really need to know about the life cycle of that consumer and their transactions for as long as we possibly can. So there's not just a economic and technical precedent for this. There's a real world. We want to track everything about a transaction as far as we can.
The other thing that we really decided at the outset and adopted at a philosophical level was we don't want to move data, right? And that's a common theme. Obviously, moving data is slow, just in the mechanics of pumping it around through a network. But we also realize that there's something incredibly powerful about having all your data in one place. The opportunity to correlate completely disparate data sets against each other is a unique thing that only happens when you don't need to move the data around. If you don't need to move it, you save a ton of time, but you also get some of these new capabilities that you never would have come up with before. There's sort of a hidden opportunity cost when your data is split and is spread around. There's conclusions you'll never come to because there's questions you're never going to ask. So having that in one place really was, sort of incredibly powerful on a number of levels. Yep. The other thing that we decided is, and this is a little bit different, we didn't want to take shortcuts, right? So we weren't looking for, hey, where's a good SQL connector so I can do this in a way that's a little bit more native. We looked at it and said, we want to be really ambitious. We want to learn MapReduce. We want to learn it well. We want to develop a core competency in the underlying technologies because in many cases we decided we may end up a little bit ahead of where the commercial products currently lie. What's great is those products tend to come up behind us and we're able to adopt more off the shelf as we go. But if you want to do something really new and really groundbreaking, I think you have to be willing to sort of be ambitious and get in there and learn how to write some custom components.
Yeah, and again, on my side of the house, and sometimes the developers get annoyed at this, but I really don't think you should go after high-level abstractions, clever libraries and whatnot until you really understand what's happening at the lowest levels. I know that's a lot to ask for a development team that is pushing hard to deliver features, but ultimately I know it's going to pay off. And for a company like ours that wants to be here forever, we need to develop that notion. And I think we've stuck to our guns for the last year and have really built some good fundamental knowledge that may in the short term have slowed down our progress on some short-term projects, but ultimately is going to pay off big time. And then having a second point on this, having watched many of these presentations today, especially like the last one, living on the edge of Hadoop is a dangerous place. I mean, there's a lot of confusing stuff, and yes, it's cool when you actually get some of these things to work, but ultimately, if you go back to the slide with some of our partners, living on the edge doesn't necessarily help us move faster. Us being very good at the fundamentals of our business helps us move faster in terms of money, which is the thing we ultimately care about.
So one of the things that we did that was a little bit different, we didn't really look at the standard proof of concepts. We actually did some of the standard stuff too, and it had a great payoff, but it was some of the least interesting aspects. So proof of concepts, they tend to be pretty small. They're a little bit simple. They're a little bit too easy to pull off. And as a result, the goals that you attain are a little bit underwhelming. And there's something really kind of special here. You can't build a proof of concept of something like the Large Hadron Collider. You got to actually build the Large Hadron Collider.
Yeah, and that's one of the statements that I give John, and I think when I first say them, he's like, what the hell did you just say? But really, when I break it down, I say, if you want to figure out the fundamental theory of physics, there's not a lot of shortcuts. And I'm not suggesting that TrueCar is working on the fundamental theory of physics or anything like that, but we do have a long-term vision of where we're trying to go, and it makes no sense just for the sake of proving that Hadoop works, which we already believe. There's no sense in doing POCs. They simply, in the case of big data, you will never be pushing enough data to prove that kind of point unless you take on the real projects that you want to accomplish.
So this slide is actually pretty amazing. We had an 11-month timeline, and that goes from having the idea and just beginning to think about Hadoop up through sort of partnering up with our vendor, getting training done, getting more and more folks trained up, building and launching real apps. One of the things that's interesting about TrueCar is data is our product, right? The thing that we actually do is publish data through websites and mobile apps. And so the data is critical to our business. It's our core offering. And this slide is amazing because a bunch of technological steps culminated in our ability to have an initial public offering. And that was something that we wouldn't have been able to pull off with our previous technologies. It is a pretty exciting outcome for a technology group like ours.
And by no means do I want the limits of PowerPoint to suggest we're done. That capability we're looking for extends way off the screen here. And that's a really important point because I think, when you're a company that's still growing and trying to figure out, the long-term thing where you want to be, it can get easy to shortcut yourself and not give yourself a chance, not to get to something like an IPO, but to exist past that. What we were laying down for these last 11, 12 months was the next 5 to 10 years of TrueCar. That's really what John and I were looking for, which means you do invest in training. You do invest in doing the fundamentals. You do invest stepping very much in a linear way through each milestone that you want to accomplish so that you're set up to really be innovative long-term when the scrutiny is really on you.
So a little bit about our setup. We have actually had some real breakthroughs in terms of the price points we've been able to hit. The timeline was exciting, 11 months from concept to multiple production apps that power our core business. But our first cluster, we built a 60-node cluster. There's a little over 2.5 petabytes of usable HDFS storage, 960 Xeon CPU cores, and over 7.5 terabytes of RAM. There's 10 gigabit networking. Those 60 nodes fit into only 3 cabinets, and we're running HDP 2.1. So the final price point on this is pretty stunning. The hardware, software, the package of services that we bought The one-time cost was approximately 23 cents per gigabyte, which is just an incredible price point and really only speaks to half of the equation, because that's just talking about the storage. We got compute with this too. The amazing other sort of way of looking at it, the ongoing expense of operating the cluster is also incredibly inexpensive. So it's 0.3 of a cent per gigabyte per month. And that's data center space, power, cooling. We were able to do this by looking at the fundamental technology. We rejected some of the common conventional wisdom. We bought cheap generic hardware. We actually purchased it directly from the channel, as opposed to going through a reseller or a VAR. And our belief really was the underlying technology supports simply ripping and replacing damaged components. So by sort of adopting that fundamental capability and making it core to our process, we were able to achieve just amazing economics.
And the key for me here on this, even though like these are the kind of slides that I let John like make and deal with, I don't have to worry about this hardware anymore. Because of those economics, we took very seriously the point that we had up there earlier with Skeletor, which is the developer shouldn't have to worry about this stuff anymore. At those price points, I don't worry. If I ever blow through that 2.5 petabytes, I can go to John, get me another 3 petabytes, and it's barely a discussion that we have to have. It's that good. So I'll step through a couple specific example production systems that we've got in the works. And I just wanted to do this in a little bit of detail to give everybody a sense that, yes, these are real things that we're doing beyond getting clusters set up and whatnot. By no means am I claiming we have made the world's most clever software on top of Hadoop. That is not our intent with what we're doing with big data yet. Our intent to get going is do TrueCar's most fundamental stuff in a Hadoop kind of way, in a way that will scale, in a way that John and I don't have to worry about this in the next 5 to 10 years. These are always difficult to figure out how to present these things at a conference, because if I were to go all the way into them, they'd be very complicated. But I'll do my best to kind of step through and give some real substance to it. The first one is talking about our vehicle data systems. So that refers to inventory, configuration, and for those of you that know automotive, some of this will sound familiar, build data, etc. We have a lot of things that every day we simply need to know about every vehicle that we can in the marketplace. The second thing is just a different use of Hadoop for us, but we process a ton of images in an intelligent way. Yes, we need to display car images on the websites and in the apps, but we also need those images to do a lot of computational intelligence for analytics, as well as things like condition reports and pricing, etc. And then the last one is the standard fare for Hadoop type things up until 2014, which is do your BI better at bigger scale, etc. So hopefully I'm going to give you a flavor of a couple different ways that we look at this. So example system one, the vehicle data. The situation here is that every day we keep track of over 8 million vehicles in the marketplace. And that can mean, where they are sitting on different dealers' lots, private sale things, the pricing, any changes in condition, etc. There's a lot of different variation of what's happening to particular vehicles. We enrich and use vehicle data in a variety of products and in a variety of internal systems. Certainly to power the market data on the websites and to our OEM partners and our affinity partners, telling them what's going on in the market. We have product called Live Offers. We have pricing systems. We have just a ton of stuff that vehicle data is obviously the central part. And in the previous non-Hadoop-based system, it would take anywhere between 6 and 24 hours to process the marketplace of vehicle data. That is not something we can go forward with. With where we want to go with our TrueCar products, we really need to be able to do this stuff in damn near real time. We're getting there. The goal with Hadoop, obviously, is to scale up. We don't want to just track the 8 million vehicles that are out there in the marketplace today. We want to track those vehicles for the last 50 years where they were at any point in the marketplace. And we actually do have that content available to us through our various divisions in our company. We want to enable attaching new enrichment and new data sources to that core vehicle data stuff in a way that doesn't, as John referred to earlier, force me to go down a really long development and deployment path. We essentially are working on developing a plug-and-play enrichment system that we can just kind of here's a new source of data that we want to attach to that VIN-based data. And then ultimately, as I said, we want to get to almost real time. Our initial crack at things is to be able to process all the vehicle data in an hour or less every day, which we have been able to achieve, and then ultimately allow speedy, real time, and small batch CRUD operations on this data as we find new data out every day. So, give you a little bit of detail on this, and I think for many of the cool things I see people doing with Hadoop, this is pretty bread and butter for using Hadoop. But we did that on purpose. We want a very stable system that's very fast. So essentially, you're getting a ton of, this is some of the basic stuff with the inventory data. You're getting a ton of dealer inventory feeds and different sources of inventory. We obviously just kind of push it as it is into HDFS. Then we start going through about 38 different business rules to process that data and attach different things to it. It's just a chain of batch processes with a bunch of map-reduced jobs. And then there are some structured data sources that we load up into Hive and attach to it. And then ultimately, to insert it into our real-time website and app serving systems, we just have a basic message queue that's taking any inserts, any CRUD operations, and pushing them out to the various website systems. So it's not a lot of fancy stuff with Hadoop, but it's the core stuff done well. Go into a little bit of detail on one of these 38 processes. Again, for those that know automotive data, you know that the vehicle identifier, the VIN, is kind of the major identifying key that you use to identify vehicles. Unfortunately, as much as that's meant to be a universal identifier, it means different things to different manufacturers. So you have to do quite a bit of work to decode VINs and get at what they actually are indicating about a vehicle. They are meant to indicate what is actually on that vehicle. Unfortunately, they don't always do that. So our challenge here in this system is to understand exactly, we need to know exactly what is on any given vehicle. And I mean that now and historically and possibly going into the future. So what we have to do is a little bit, it's not machine learning, it's some basic F1 score stuff where we have a couple different data sources that we're stitching together as we do the processing, and then we calculate this F1 score to stitch to calculate the similarity between different data sources, suggesting what exactly that VIN against different sources that might be reporting different things about that VIN, what is likely the exact stuff that's on that vehicle. And again, this is just, I'm giving you a kind of a 10,000-foot view into just one of these processes that's done completely in Hadoop. And it's actually very simple. It's just a simple mapper that does all this and then ultimately spits everything out in Avro format for use to tag other data as it goes through. Okay, second system, the intelligent image processing. So here our situation is this, and again, we're not Facebook or any other social media scale kind of thing, but we do have significant scale, and it's kind of surprising when you look at the numbers. We currently, online right now, to service everything we do, have over 250 million images that we have to make sure are correct and in the right place, etc. We've already processed over 1 billion different images in our lifetime, and we're currently, and it's growing, you know, over 1 million images a day, just raw vehicle images that we haven't seen before that we have to do something with. The original system sometimes takes over a day to complete. Obviously, that's not good enough. Our intent is to be able to scale almost 4x in terms of how many images we keep online at any given time. I'd never have to worry about that, but it will, you know, 1 billion or more is a good goal. We need to allow, again, for plug-and-play ability to develop advanced processing aspects like image recognition, OCR, and some other clever things that we're doing. And then ultimately, I need to be able to run a full data set. If I had to rerun the whole damn thing because I invented some cool algorithm, I need to be able to do it in less than 2 hours, and again, handle real-time updates to any particular image, you know, in real time. So just a little bit, and some of this, you know, maybe for those that do image processing, it might not be like super clever. But initially, the big thing, you know, obvious thing, but it's kind of brute force. You need to be able to download a lot of images very quickly. Hadoop makes this super trivial because you can just fire up a bunch of mappers kind of stupidly and go rapidly grab as many images as you can. Your only limit usually is by the image hosters who might be rate limiting how fast you can do things. The relevant point here is that, again, I can go to John and say, if I ever need to scale more than I can today, just throw more boxes in the cluster and I'll fire up more mappers. Second, and this gets into a little bit more of what's actually going on. So to do interesting things, once we have the raw image data downloaded, we use a library called Hippie, which is a Hadoop image processing system. It's just a library that actually doesn't do a ton of work for you, but it does make it handy to use Hadoop in a way that you can process images efficiently and not totally blow up a bunch of things. Basically what it does is it allows you to bundle a ton of images into a larger HDFS file that you can also go do actual routines within that image bundle. This just makes it a little more sane to actually deal with and kind of sticks with some best practices on block size and whatnot in Hadoop. Another relevant point is the ability for us to, we just tag the metadata right in the image, which is a common usage pattern in Hadoop. Keep the data, the metadata flowing with the actual data so that different applications can use the data without having to redesign a bunch of schemas or fire up different databases to keep track of that stuff. So the intelligence part of this on the next slide gets into some of the things that we do, and it's not all of them. We do a bunch of OCR, thumbnailing, those types of things, just using some nice MapReduce jobs. And again, because we're doing it all native MapReduce in Java, you can usually pick some components off the shelf that are common libraries, OpenCV, et cetera, to get a lot of bang for your buck without having to reinvent the wheel. As we move down the slide here, you get into some of the more interesting things that you have to do with automotive data, which is figuring out the color of a vehicle is actually an insanely difficult thing because, again, the manufacturers all use different color schemes and how they name different colors, and it has a material impact on the price. So you can't do generalized color mapping, like this is red, this is green, this is blue. That won't do. Because if you don't have, I don't know, ladybug red, it may affect the price by $1,000 or something like that. So if you're going to use vehicle images to figure out colors, you really got to have some real intelligence in there. And then the last thing is that, again, it's really interesting how things work, but in terms of customers, but being able to detect the orientation of a vehicle so that you can correctly display it in apps and websites is really important. It actually has a very big impact on things like conversion rate. There's certainly a bunch of other things that we are doing with images that I don't have time to go into. So the third system I'll let John talk about.
Sure. So, BI is a very common use case for Hadoop. It's where a lot of people start. And we did, one of our projects was sort of the standard thing. We've got guys using Tableau, and being able to point Tableau at a SQL connector on Hive and Hadoop, and with a product called Arcadia Data, was a great sort of win for us, but probably one of the less thrilling wins that we had. And that's only because some of the other things that become available to us are even more revolutionary. So first of all, we're able to look at a far larger data set, different types of data, because unstructured data is now easily available through Java and through intelligent parsers that we write. You can really correlate to a lot more sort of behavioral data that goes beyond just web clicks and things like that. And finally, there is an aspect of this where, traditional BI is come up with a question and be really good at getting an answer. We're moving towards a more open-ended correlation hunting model where because all the data is in one place, you can actually compare things more easily across different parts of the business. And we've reached some startling conclusions, including things like, you sell less cars when cash hit rate is low. And that's really a synthesis of purely technological instrumentation from the bowels of IT with the traditional BI metrics. And that would be a question we would never know to go ask.
Yep. Good. So to give you some sense, and again, I'm not going to, there are people here working with 10, 20, 40 petabytes of data. So by no means are we the biggest data shop in the land, but this does, John and I looked at curves like this, and this is just one data source internally, one source of BI data for us. And when your curves start to look like this over a 2-3 year period, and you don't have certain amounts of infrastructure, you start to get really nervous because that curve is not doing that, it's doing this, which, with other aspects of our business, that's happening. And so John and I look at this kind of thing and say, okay, every day online now we got to track 2 billion, of these events that I'm suggesting here in this graph. how's that curve gonna go for the next 2-3 years? Because, and can I support that? I don't want to have to rebuild everything. So it's just, for us, this is now, instead of being a worry, this is actually a good thing. Now our problem is on my team, how as developers and intelligence engineers can we take advantage of the fact that that data we will have available to us forever to use in all our applications. And then here, just, of course, these are just graphics showing, our appetite to do more real-time, multi-dimensional BI. It's super important. We look at a lot of different ways of visualizing the industry and exposing those visualizations and that data to our industry partners, our dealers, as well as our consumers.
So, was it worth it? Obviously, we ended up with some pretty fantastic results from this. When we were previously looking at storage solutions that were really just pure storage that scaled up into the petabytes, we were looking at a sort of tens of dollars per gigabyte type number. So bringing that down to 23 cents a gigabyte, it's more than just an economic savings. It fundamentally transformed how we looked at data and how we looked at our business and changed the ideas that we had for doing things with data. We also were able to eliminate some expensive proprietary tools, so there was an extra savings there. What's really kind of interesting about this, though, looking back on it and seeing some of the cool capabilities that we've come up with, we would have paid more to get those capabilities, right? So cost savings wasn't even initially the driver, but it was just a stunning side effect of the approach that we took, and I think it really made it worth it to jump in with both feet. So we were also able to slash the amount of time it takes to develop complicated applications, and this is really because our guys who know the business, who are smart, they spend less of their time on the mechanics of things like SQL and how do I shard my giant data set, and instead they focus on the part of the problem that's unique to us and that adds value to our business. So at a high level, it's just more brain power going to improving the business. Automated trend hunting, this is sort of one of our interesting future areas of exploration. You get a lot of data in one place. You start to just do open-ended correlation hunting. And running a business is not pure science. In pure science, you want to watch out for different kind of biases. In business, it's the opposite. I would like to see every crazy conclusion that comes out of this data, and then I'll go run those down. And instead of having executives who are very smart guys who try to think of the right questions to ask, we can actually go back to them with, here are unbelievable insights about our business. And now their brain power goes to, how do I operationalize these and turn them into success for the company, as opposed to, how do I dream up what the question should be so that I get a smart answer. We have a unified ETL and storage system. So our goal is zero data movement. And again, that's not only because data movement is a logistical nightmare, it's also because these new opportunities that come up, we've discovered that we were hindered in the kind of questions we asked and the kinds of answers that we got by these sort of hidden properties of the technology. So by freeing ourselves from those constraints and adopting a more functional programming approach, again, it just fundamentally changed how we looked at data and looked at our business.
Yeah, and the last one's mine for those that are into these kind of things. I very much believe in a functional programming approach, which is really do your best up front to not have side effects is the way that I like to think about the biggest benefit. And I think MapReduce and Hadoop kind of forces you to think very hard about how am I going to scale up, how am I going to do this so that I don't have to worry about, 2 months down the road, is this going to have all sorts of weird side effects that I didn't know about. So definitely worth it.
So when we look forward to the future, we've got a lot of really exciting things that we're working on. Our mobile apps really depend on real-time, instantaneous data. And the secret to that is going to be sort of marketplace simulation. If you want to simulate a marketplace in real time, we can actually crunch every possible permutation of the marketplace the night before on our cluster and push a lookup table into the front end. So the reality is we already know the answer to every possible outcome. And then we get lightning fast results. When you're standing there on a car dealer's lot with a phone in your hand, that's the kind of data you need to power the future of the experience.
Thank you very much. Appreciate it.
Thanks, guys.